Okay, hey Block 3 students. So here's our video for the POW. This is actually POW number 4, which is about long division. So today we're talking about long division and how long division works and why we use this algorithm. So the first thing you were asked to do is think about why is it problematic that we are never talking to students about how the long division algorithm works. And I'm actually going to return to that in just a second. I'm going to skip to number 2 first. So number 2 asks you to do 720 divided by 6 using the long division algorithm. So for this problem, what we would do is we would say, well, how many times does 6 go into 7? It goes in 1 time. 1 times 6 is 6. Then we do 7 minus 6 is 1. Carry down the 2. 6 goes into 12 2 times. We write 12 down here. And then we drop the 0. 6 goes into 0 0 times. So in number 3, you were then asked, can you think of another way to figure out how many times or how to do 720 divided by 6? So let's think about it this way. Let's take the number 720 and try to divide it up into 3 groups, first of all. Actually, we'll go ahead and do all 6 groups. So 4, 5, 6. So the first thing I might do is deal with 100. Just do 100 at a time. So because I know that I can at least get 6 hundreds, so let's do that. So we'll put 100 in each group. Right? Well, now that I've put 100 in each group, how many is left? Well, that's 600, so what I'm left with is 120 that I have to dole out now. So I could go in a number of ways. I could dole out 10 at a time, so let's do that. Let's do 10, 10, 10, 10, 10, 10. Oh, how many did I just get rid of? Well, 6 tens make 60, so now I'm left with 60. Well, how many times am I going to go back around with 10? Once more. Right? And then I've used up all of my 60. So what's the answer? How many times can we divide, or what do we get when we divide 720 by 6? Well, the answer to this would be how many is in each group, which is 100, plus 10 is 120. Let's think about it a different way. We could dole 720 into 6 groups again. Or let's think of it this way. Instead of partitive, let's do it the other way that we talked about in class where, so in this case, we knew how many cups and we were trying to figure out how many chips went in. What if we thought of it the other way, which is we know how many chips are going to go in each cup, which is 6, but we don't know how many cups we'll need. So essentially what that means is subtracting 6 and figure out how many times could we subtract 6 where we would get to 0. So let's try it once. So 720 minus 6 gets us 714, right? Let's do it again. Well, then I get 708. Let's do it again. And I get 702. And around this time I realize, whew, this is going to take me a long, long time. So then I say, scratch that. Let's subtract by groups of 6 at a time. Instead of a single 6, let's take off 10 6s. So I'm going to do 10 6s, which is 60. So over here, let's keep track of how many 6s I've done. So this is 10 6s. So 720 minus 60 is 660. Then I could subtract off another group of 10 to get 600. And around here, I might realize, hey, you know what? 60 goes into 600 10 times. So if I take off that 600, that is equal to 100 6s, right? which gets me down to 0. So how many 6s in all did I take off? How many 6s did I subtract? I subtracted 100 6s, and then 2 groups of 10, which is 120. So let's look back at our long division algorithm. Let's look at what we're actually doing here. When we do 6 divided into 720, and we ask ourselves, how many times does 6 go into 7? What are we actually asking? Well, we've changed. What we're doing is we're saying, instead of doing 6 into 720, we're doing 6 into 700, and then seeing what's left over. So how many 6s go into 700? Well, 100 of them, right? 100 6s will go into 700, and it will get us 600. And then, so just like here, we've taken off 600s, so what's left? 100. But then we also have to account for the 20 we left behind. So now we have a new number. We have 6 into 120. And then we can ask ourselves, well, how many times does 6 go into 120? Well, it goes in 20 times. So that's where we get this 120. We're just adding up the total number of 6s, or the total number you could put in 6 groups. What's key to understanding this is that unlike this method, where we take off 1 6 at a time, where what we're going to see is that we're taking it off in the ones place, we're trying to think of what's the speediest way that we could do this. So in this method over here, the way we might write this is 720, let's go ahead and take off 600 straight off the top, right? That's 100 6s. Let's just subtract 100 6s straight off the top, right? So when we do that, we get our 120. And then we might say, well, that's at least another group of 10. And in fact, it's a group of 20 6s, right? Which comes back to 0. So that's all we're doing in the standard division algorithm. But what's key to understanding this is realizing that unlike every other algorithm that we teach children, this one makes children go from biggest place value to smallest place value, which is crazy, not because it's wrong, but because we never talk to children about why we might do that, why we might start with the largest number at a time. And the reason is because it's efficient. It's way more efficient to take off a group of hundreds at once rather than to take off 1 6 at a time, which is what we would essentially be doing if we started with the ones place. So if you want to explore more about this, I encourage you to try doing some other problems and seeing if you can figure out what happens when you do start with the ones place. So for instance, if you were to do 864 and divide that by 12. Think about how you might do that with the long division algorithm versus how you might do it with the dole-out method versus how you might do it with subtracting off. And see if you can try to make sense of that. All right, see you in class.